we've been really fast and loose about the term variable and event or state. And we've almost talked as if those two things were interchangeable. There's just some letter there in a probability expression. But now it's time to get more explicit about that. So going back to this Venn diagram picture of probability, let's just imagine there's a big circle representing the set of all possible events that we're going to consider. Then I'm going to define a random variable as being just some way, some way of slicing up that complete Venn diagram into disjoint pieces. If we can do that, then we've defined a discrete variable, and those separate disjoint regions of my set of all possible events now represent, each one of those represents one discrete value of my variable, which you could also call a state of the variable. And if I say it's a random variable, you could basically think of it as like that Venn diagram is like a dartboard, and I'm just taking a dart, blindfolded, throwing the dart randomly, it lands randomly somewhere on the Venn diagram, and the slice that it lands in, that's the value that we just drew from a random sampling process from our probability distribution. Okay? So when we talk about joint probability distributions, multiple variables, what exactly does that mean? Does it mean we threw the dart more than once and we got values for 5 different variables? No. What it means is we have 5 different ways of slicing the Venn diagram. Each method of slicing represents one variable and its set of possible states. Okay? So I've got a variable x, and maybe all my slices are sort of marching along horizontally, maybe, on my Venn diagram. Maybe I've got a variable y, and now I'm slicing, vertically. Obviously, those slicings overlap with each other, so the dart lands in a particular spot in the Venn diagram. I just drew one particular value of my y variable and one particular value of my x variable, basically the slices that dart landed in. Does that picture make sense to you? So one more little convention for how I'm going to write things. I'm going to write random variables using capital letters, and when I need to explicitly refer to the idea of a specific state of that variable, I'm going to use a lowercase letter. So an expression like this, p of capital X equals little x, that means it's the probability of random variable x being drawn or drawing the specific value little x. And throughout all this, I'm making the simplifying assumption that I'm talking about a discrete variable. Right? So I think all this stuff becomes a little bit clearer why it's important to make these distinctions when we look at some problems. Okay, so as I just said, when we have different random variables, you could think of it as different ways of slicing up in whatever way you want our total Venn diagram. And another way of thinking about it is correlation. For example, I might have 2 different slicings of my Venn diagram that look pretty similar to each other. So what's going to happen? What's going to happen is there's going to be a strong correlation between the values for those 2 random variables that are represented by those 2 slicings. Does that make sense? if I have, imagine it's sort of stripes like that, and then I have another set of stripes that are, at an angle that's pretty close to the vertical. Then I start throwing darts randomly, drawing pairs of values from those two slicings. You're going to see a strong correlation. I tend to draw from the first stripe of my x variable. I'm probably also going to be drawing from my first slightly angled stripe of my second variable. Right? So the fact that I say that they're different slicings doesn't mean that they're not similar to each other, or perhaps even exactly identical to each other. But I'm simply saying I get to label two different sets of divisions on my window. Any questions?